Today's episode is brought to you by NBA star Lonnie Walker and PETA, the People for the Ethical Treatment of Animals. Warning, dogs can die in hot cars. It's too hot to leave your dog in the car. Well, duh. Yeah, I knew that already. Well, did you know that leaving the windows down is still too dangerous? Oh, really? Okay, we'll just park in the shade. Do you want to go to jail for animal abuse? Okay. I have a dog and I don't want to hurt my dog. So let's learn about car temperature pet safety. I just don't understand how a car temperature can increase 34 degrees in just 30 minutes. Well, I have good news for you, my friend. We're going to take what we learned from this and turn a really bad idea into a really good idea called a solar oven. Heat trap! We're going to be talking about sources of heat energy, and we're going to illustrate the effect of sunlight on various objects. We're going to use tools and everyday materials to design and construct a device that will increase warming effects of sunlight. First, we need to talk about a thermometer. What is a thermometer? It's actually a thermometer. Thermo means heat, meter means measure. So heat measurer makes sense, doesn't it, for a thermometer or thermometer. Why is there an F and a C on the thermometer? What does the F mean? What does the C mean? If you said Daniel Gabriel Fahrenheit and Anders Celsius, then you know more than I did. So which one is correct? Fahrenheit or Celsius? Actually, Lord Kelvin is correct. Wait, what? Yeah, there's actually lots of different standards for measuring heat. The good news is we only need to know about two, Fahrenheit and Celsius, and the correct answer is they're both correct. So which country in the world, there's only one that still uses Fahrenheit. Everybody else uses Celsius. Who do you think it is that uses Fahrenheit? If you said the United States, you are correct. It looks like two, but actually that's Alaska on the top there, and then the lower 48 states, and then Hawaii is also. So the United States still uses Fahrenheit, so we need to know that, but the rest of the world, including scientists around the world, all use Celsius. We will learn more about them later, but let's get to our activity for today. This is a digital thermometer. I don't understand how it works, but you could point it at anything and it will tell you the temperature. So the ground temperature right now is 112, but the inside temperature is 147. So it actually is working. It is, even higher. It's pretty hot, sweating out here. Try my forehead. 98 is my internal temperature, but my forehead is 94. Pretty cool. In just a few minutes, you can see how the temperature on this one 110 and the one that's inside 130, 140. So just a few minutes, it's already heated up. Angle this top flap here. So I'm looking for the reflection of the light down on the black paper, and it looks like somewhere around there. My new contraption's not working either. Look, the wind is moving it all around. I have to find a new strategy. Okay, 20 minutes later, and the internal temperature is almost 170 on that thermometer. Let's check this one. Interesting. So now, because I'm using this big box, I think the air is leaking out of here. The heat, I think, is escaping. I have made two solar ovens, and you see the banana for scale there. The really big one and the really small one. And I found the small one is just much easier to manage because we have to seal up all the edges to keep the heat in. And so I'm now sticking with the smaller one. I used time lapse to show it melting in a faster speed, and my hand was too shaky. So I went in and got a stool to put it on. And that seemed to work until the iPad stopped working. Turns out the iPad overheated. Why? Because the iPad is mostly black and it's absorbing the sunlight, converting it into heat and overheating. Ooh, that cooled off quick. I'm losing heat here, people. Where's the heat going? Because I duct taped it. So I love how YouTube offers so many different ways to do things. Kind of do-it-yourself lessons.
But I'm surprised how many of the videos I've seen have explained that the plastic part here is only to keep the bugs out.
No!
And that's not true. The plastic wrap there allows the sunlight to shine through, and the sunlight hits the black paper and converts the sunlight, the radiation, into heat. But the plastic also is like a blanket. It's like an invisible blanket. So once it heats up inside, the heat gets trapped. Just like the windows of a car, when the windows are up, they trap the heat. Of course, the sunlight can shine through, but the heat cannot escape. So you have to have your plastic wrap there, not to keep the bugs out, but to keep the heat in, while also letting the sunlight to shine in.
So I wonder what would happen if instead of using one reflector or one aluminum covered side, if we used 4. If that increased the amount of light shining into the solar oven, how would that affect the temperature, do you think? I had trouble keeping the small pizza box lid in place, so I used aluminum foil on a big box, and then I remembered we have mirrors. And so I taped a bunch of the mirrors together, and I pointed to all of that at our solar oven. What do you think happened then?
Whew, it is hot.
Heat trap!
And 205 in the solar oven, and 105. So wow, 100 degrees warmer in that box. Because why?
Heat trap!
Because the plastic cover is keeping the heat in while the light passes through. It gets absorbed by the black paper and heats it up. Solar oven's working.
Heat trap!
So downside to taping your box closed is when it falls over and covers up your thermometer, it also is hard to open. That's all right. At this point, I'm just curious about the temperature. It's a little warm out here. So I'm gonna do the test here. My prediction is my forehead will still only be 90-something degrees because I'm sweating. That's how the body cools itself. Look at that. 92 degrees. Wonder what my shirt is. 101, look at that. My shirt's 101, but my forehead is 91. Wow! 10 degrees cooler because I'm sweating. Nice. Unexpected result of an experiment is ants. Gotta find a way to keep the ants away. It melted though. But yeah, ants. Different arrangement this time. Now I'm using this mirror that collects a lot of the sunlight.
And I just happen to have this mirror from an Euler's disc, which is basically a stand for spinning stuff around. It looks like Euler, but it's pronounced Euler. And the Euler's disc is famous because does it roll or does it spin? And the answer is yes. It does both, and they call it sprolling. It's important to point out that I have not made this faster in iMovie. This is actual speed.
And focus it in. Woo-hoo-hoo-hoo. Now we're roasting some marshmallows. That's just a mirror, a concave mirror. Ooh, I can see the heat coming off the top of it. You can actually see the heat waves. 710? What? Wow. That's just a mirror focused on the marshmallow. Not insulated at all. 456, 367. I just love the smell of roasted marshmallow in the morning. Oh no! Oh my goodness. I didn't think this was gonna happen. I just busted the thermometer. It popped. They went too high and now it's leaking out. Whoa, that's hot. I didn't know a thermometer could do that. But I guess that makes sense. I have to say I'm pleasantly surprised with this version. 139 degrees in there, And you can actually see the plastic getting pushed up and out as the heat inside expands the air molecules, and that's a sign that it is heating up. And so is comparing the temperature inside to the temperature outside. So it is catching the heat, capturing the heat, holding the heat.
Heat trap!
And getting warmer all the time. So you probably don't have an infrared thermometer at home, or even a regular thermometer, but you don't need one, because the marshmallow and the chocolate are the thermometer. They're measuring the heat by melting and showing the heat is increasing. What a sweet thermometer. All right, how do we make this heat trap?
Heat trap!
Also known as a solar oven. You're gonna start with a box. This is my hand, so about the size of my hand. It's just easier to manage a box that size, but you could try a bigger one if you like. And using a ruler, you're gonna draw 1, 2, 3 lines. And then with your parents' help, you're gonna cut out those 3 lines to open up like this. It helps to use the ruler back here, so when you open it, it folds on a straight line along that ruler, and that's just gonna make it easier door to work with. See, I kind of tore mine accidentally. I should have put the ruler here, folded it that way instead. All right, the next thing we're gonna do is you're gonna open this up and we're gonna put plastic wrap across here. You can lay it across the top and tape it down, or you can lay it across the bottom and tape it down. Plastic wrap's a little bit tricky to work with. It just takes some practice. So I find if you do one side and tape it, and then cut it, and then do the other side, it'll be better. So what is this? This is our blanket. This is our heat holder. So the light will pass through the plastic, and it will heat up the air inside, and the air inside was trapped, and it cannot escape through the plastic. All right, now with some aluminum foil, I'm gonna seal up the edges and the cracks in the box here. So I'm just gonna put this down. You want the shiny side up. Shinier side up. And then you can just fold that over. And careful not to tear it. It actually does tear pretty easily. Okay, so now I've sealed up the edges. Now I need to put down the light sponge. Ha! So black absorbs light and heat, and so I'm gonna roughly measure this out. And now I'm gonna put my heat sponge, my black paper, like this. All right, so now I have my light heat sponge. I have my blanket across the bottom to hold the heat in. I've got my invisible blanket across the top, letting light through, but trapping the heat on the air molecules. Now, one last thing. I need to put some shiny reflective material here to bounce the light down through the plastic wrap. Again, I want the shiny side facing up, like this. And I heard in one of the videos, the smoother this is, the better.
For directing the light.
All right, so ooh, I see it reflecting the light already. Nice. So what do we have? We have a cardboard box with aluminum foil across the bottom, like a blanket across the bottom, a light heat sponge that's going to soak up the light, the sunlight, turn that into heat in a black paper. We have a window where the light can shine through, but the air, the heated air cannot go through. And whoops, what do we need? We need our s'more. Now I know what you're thinking. What is that on the bottom? I don't have any crackers, and I don't want the marshmallow to stick to the paper. So I'm using a tortilla. Now tortilla is white, and white reflects the light. I don't want to do that. I want the black to absorb the light. So that's why I cut this tortilla to just enough size to hold the marshmallow and the chocolate when it melts. I'm gonna set that in the middle there. And then seal it up. I'm tempted to tape the edges here, but if this falls over, I have to untape everything. So I'm going to try it like this and see if it works. And I've got my light reflector here to shine that light down into the box. You can see that working there. And I'm ready to make some s'mores with my heat trap solar oven.
Wait, don't go yet. Check out this bonus challenge.
Last but not least, bonus points if you want to go for the extra cool heat trap. This one I saw online. I pretty much finished this lesson and then I saw this. I'm like, oh, we're not done yet. I'm going to try this one out. And I love the idea of being able to open the lid to reach in and out and then just close the lid closer to being airtight. You're probably going to want to put some aluminum foil on this just to keep the light from escaping out and then losing heat. So how does this work? Got your can, draw your lines, use the ruler to fold it open, and then the plastic wrap, I just laid it out across the top and then I taped it all the way across there. And then I just rolled a piece of aluminum foil like this and slid it in there. And then some black paper. I don't know if you want to put your chocolate right on there. You have a cracker, it would be better. Like this. And then you put your s'more in there. And just pop the top. Put the lid on there. And it's closer to airtight. And good to go. You are going to want something behind it like a rock outside. Otherwise it will tip over. But you can use that to adjust how the light is reflected down in there. As you can see, the inside of the can is already reflective. But I figured the more reflective, the better. So I went ahead and added another piece of aluminum foil to the flip lid here with the shiny side facing the inside of the can there. Super cool solar oven heat trap. Good luck. Can't wait to see your results on Flipgrid.